Welcome to the system. I'm an architect. Where people see problems, I see a system. The system is in place, the rules are in effect, results are being measured, feedback is being gathered, but time passes, people change, the market changes, data changes, needs change, and one day, even though the system is still running, it no longer serves the right purpose. People call this a failure. Sometimes they're wrong. The problem isn't that the system has stopped. The problem is that, while it keeps running, it falls behind reality. In log 021, we learned to listen to what an action actually changes. We established the cycle of measurement, feedback, and learning. But even a learning system can lose its way over time. Because a rule that was correct yesterday may produce the wrong result today. A boundary that provided protection yesterday may become an obstacle today. Automation that sped things up yesterday may create a new dependency today. This is how silent drift begins. A system doesn't break down all at once. First, small differences emerge. A process takes a little longer. An exception appears more frequently. People start working around the rule instead of following it. A new need is squeezed into old spaces. The reports are still in order. The boxes are still green. But the reality within the system has changed. An architect doesn't just look for errors. They look for deviations, because an error is the crossing of a defined boundary. A deviation, however, is when that boundary no longer represents reality. A customer model changes, but the process remains the same. A team grows, but the decision-making process is designed for the old pace. A product multiplies, but the data structure still behaves as if there were only one product. And automation works perfectly in the early days. Then people change their behavior to accommodate it. The system remains the same. Its environment changes, and the gap grows a little more each day. People are afraid to touch a working system. Don't break it, they say. Yet some systems break precisely because they are left untouched. Because order is not stagnation. It is a balance that can adapt to a changing reality. For an architect, maintenance isn't just about fixing a malfunction. It's about asking whether the system still serves its original purpose. Why was this rule in place? What was this boundary protecting? What behavior does this metric guide? Is this step still necessary today? When these questions aren't asked, processes lose sight of their purpose. An approval gate continues to guard against a risk that arose years ago. The risk is gone. The gate remains. A report no longer influences anyone's decision. Yet, it's prepared every week. A field goes unused. Yet, everyone is required to fill it out. This is where the system ceases to be architecture. It becomes a ritual. People follow the rules, but the rules no longer lead them in the right direction. That is why the architect looks for an expiration date within every functioning structure. When will the rule be re-examined? What change could render it invalid? What signal will indicate that the system has become disconnected from its environment? Who will have the authority to stop it when they notice this? Without these questions, the system imposes the decisions of the past onto the future. The most dangerous aspect of silent deviation is that it doesn't appear to be a failure. The process is completed, a report is generated, automation is triggered, but the output drifts a little further from the actual need. Then people make small adjustments. They add notes, they send messages, they open another table next to the original one. New workarounds emerge outside the system. When these workarounds multiply, people are perceived as undisciplined. The architect, however, sees something else. People are trying to compensate for an architecture that doesn't align with reality with their own hands. Temporary solutions are not always the fault of the workers. They are proof that the system refuses to change, but not every change is correct either. If the system reshapes itself according to every new demand, it loses its identity. Today's noise becomes tomorrow's rule. That is why the architect distinguishes between adaptation and being swept away. Is a signal repeating itself? Is it appearing in more than one place? Is it truly affecting the purpose? Is it temporary or permanent? If no changes are made, which cost will increase? These questions guide changes to the system based on reality, not trends. The maturity of a structure does not lie in its never changing. It lies in knowing what to preserve and what to let go of. Because every system needs two things at the same time: identity, adaptability. Without identity, it loses its direction. Without adaptability, it falls behind the times. The architect does not eliminate the tension between these two. He manages it. The system's purpose may remain fixed, but the path to that purpose may change. The value being preserved may remain the same, but the rule that protects it can be rewritten. This is what true maintenance is all about: making room for the future without erasing the past. Because time tests every system, and the only thing that never changes is that change will reach the system. A silent deviation rarely stems from a single major mistake. It forms through the accumulation of small compromises. A rule is bent once today, a second time tomorrow, then the exception becomes the norm. After a while, no one remembers why the original rule existed in the first place. They just know it's easier to work around it. This is how technical debt accumulates. An architect sees these hidden debts as well: technical debt, process debt, decision debt, knowledge debt. Each carries a burden left for the future to make today easier. A temporary workaround is implemented, a quick fix is implemented, a verification step is skipped, an integration is left to be fixed later. At that moment, the problem appears to be solved, but the system pays the price for this shortcut in the future. Because temporary solutions don't disappear on their own, people get used to them, new processes are built on top of them. Then removing them becomes more expensive than setting them up in the first place. That's why the architect doesn't trust the word temporary. If a solution is temporary, when will it be removed? Who will remove it? Under what conditions will it be deemed unnecessary? If these questions remain unanswered, a temporary solution becomes unnamed, permanent architecture. Another source of silent drift is metrics. When a metric is first established, it can encourage the right behavior. But people adapt to what is being measured. Over time, the goal and the metric drift apart. A team increases the number of closed cases, but it puts off tackling the tough problems. A system increases processing speed, but people end up having to make more corrections. The report still shows success. The reality, however, is heading in a different direction. The architect doesn't blame the number. Instead, they ask what the number actually represents now. Is this metric still aligned with the goal? What does it make visible? What does it hide? Over time, a metric can become part of the behavior game. When the system begins to deviate, the first sign is often not an error, it is friction. People provide more explanations, they take more notes, they repeat the same task in two different places. The official path diverges from the actual path. On paper, the process looks different. In reality, people follow a different route. The architect does not interpret this difference as a lack of discipline. Instead, the architect sees it as a signal that architecture's response to reality has weakened. However, not every shortcut is legitimate. Some compromise safety, some make responsibility invisible. That is why the architect first identifies the cause. Why is a person circumventing the rule? Is it because the rule is unnecessary? Is it because the process is too cumbersome? Is it because of a lack of authority? Or is it to avoid responsibility? The same behavior can stem from different causes. A misdiagnosis produces new deviations. That is why maintenance is not merely cleaning. It is a reassessment of the decision: which parts still serve the purpose, which ones merely carry the weight of the past, which ones have created new risks. Removing a step from a system requires just as much care as adding a new one, because some controls may seem unnecessary, yet they might be preventing a rare disaster. An architect does not rush through change. First, they examine the system's history. What event led to this rule? What risk was it added to mitigate? Does that risk still exist? Has another safeguard been established? Simplification carried out without understanding this history can reopen a forgotten wound. Blindly clinging to the past also ages the system. Just because a rule was once correct does not mean it will remain correct forever. The architect shows loyalty not to the rule, but to the purpose. If the purpose is preserved, the path can change. If the value is preserved, the method can be renewed. To stop silent drift, there must be review points built into the system's own rhythm. Some rules are reviewed according to a schedule, some when a certain threshold is crossed, some when a new product, market, or risk emerges. A schedule alone is not enough. A trigger is also needed. If exceptions are increasing, if wait times are getting longer, if people are doing more work outside the system, if the same problem keeps recurring, these indicate that the architecture has become disconnected from its environment. However, a review does not mean rebuilding everything from scratch. Sometimes a single rule is removed, sometimes a limit is expanded, sometimes a temporary solution is made official, sometimes the workaround is eliminated, and the core process is strengthened. Maturity does not lie in the magnitude of change, it lies in the ability to address the right issue. An architect does not examine the system to break it. They examine it to correct its course, while the deviation is still small, because major collapses do not begin in a single day. They are the result of small frictions that go unnoticed for a long time. A system's future depends not only on how robustly it was built, but also on how honestly it can see itself when it changes. It is not necessary to shut down the system to stop a silent deviation. It must be reconnected to reality. The architect first makes the purpose visible. Why did this structure exist? Who was it protecting? What outcome was it meant to produce? Then they look at the present. Is the same need still there? Have the risks changed? Is the system's outcome still aligned with its original purpose? Renovation carried out without answering these questions merely changes the form, not the essence. Some systems appear new but continue to operate based on old thinking. The interface changes, the tools change, the name changes, the decision-making logic remains the same. An architect does not mistake cosmetic changes for maintenance. True maintenance is remembering why the structure exists in the first place. Renewing a system requires 3 steps: identifying what needs to be preserved, separating what has become a burden, redefining the boundaries according to the new reality. It's easy to erase everything. It's also easy to preserve everything. The hard part is distinguishing which parts define its identity and which are mere habits. An approval step might be safeguarding security, or it might be a remnant of a fear from the past. A report might be improving the quality of decision-making, or it might be a ritual that no one reads. An architect does not judge a component in isolation. They look at its impact within the system. What breaks if it is removed? What costs increase if it remains? What new risks arise if it changes? These questions transform renewal from a mere reaction. It transforms it into architecture. A silent deviation should not be corrected all at once, because invisible dependencies form around old systems. People develop habits based on them. Other processes become tied to its output. When a table is removed, another team may lose information. When a rule is relaxed, an old control gap may open up. That's why the architect tests changes in small areas, observes their impact, then expands the scope, preserves the previous version. They leave the path back open. Controlled renewal does not mean severing all ties with the past. It means carrying the memory to be able to revert if a step goes wrong. A silent deviation is not visible from a single screen. The operator sees the friction. The customer experiences the result. The manager sees the risk. The technical team sees the dependencies. The architect brings these perspectives together in one place, because even when the parts work correctly, the whole can go in the wrong direction. A review is not a report meeting. It is a reckoning, but not with people, with assumptions. What did we believe yesterday? What has changed today? Which decision is still based on evidence? Which one is accepted as true simply because it's been repeated? A mature system respects its past, but it does not obey it. An architect does not erase the past, he places it in its context. When a rule is removed, the reason is recorded. When a boundary changes, the sign that made it necessary remains visible. Thus, the system does not merely change, it also knows why it changed. Without this memory, an update quickly turns into a new deviation. Because people remember the change, they forget the reason. The system's maintenance rhythm should not constantly trigger alarms. Not every change is a crisis. Some signals are monitored, some require minor adjustments, others call for a rethinking of the structure. The architect sets thresholds. If exceptions increase, an investigation begins. If off-system operations multiply, the true path is mapped out. If the same error recurs, the root assumption is questioned. If a metric does not represent a purpose, it is redefined. In this way, maintenance becomes a reflex grounded in reality, rather than a habit tied to a schedule. You don't have to rebuild your entire system today. Choose a single rule that everyone is accustomed to. Then write down these questions. Why was this rule established? What purpose does it serve today? Why do people work around it? What risks would arise if it were removed? What outcomes would improve if it were changed? When will it be reviewed again? When you answer these questions honestly, the deviation becomes apparent. Because broken systems don't always make noise. Some operate silently. They produce reports. They complete tasks. And every day they drift a little further from their purpose. In log 0T1, we enabled the system to hear the echo. In log 0T2, we saw how this echo signaled the changing reality. Now the system isn't just learning. It can also question its own rules. It knows what to preserve, what to let go of, when to change, and how not to lose its identity while changing. In this log, I didn't just show you the silent deviation. I also left behind the mindset that renews a system without trapping it in its past. You can see up close on synthlog.tech how the architect distinguishes between outdated rules and renew systems. I am the architect. We'll meet again in the next recording. When that day comes, you'll understand why these recordings exist. System status, active protocol, ESO2, complete, next protocol, ESO23, status, active.